Welcome to Chapter 12, Part 2. We're going to look into a little bit of a different perspective on trig functions and look at the graphs that they make. This is super helpful in basically almost every kind of sciences and in business, finance, so let's get into it. It'll be fun. So up until this point, we've been looking at trig functions and using them with triangles, finding angles, sides, stuff like that. But if you were to plug that into your calculator and get a graph, you might be surprised at the graph that we get. So the graph for at least sine and cosine is going to look like this. This is what we call a periodic function. So I mentioned this is super helpful in a wide variety of different aspects, but specifically, so things like science. So if you've taken chemistry, you may have seen a graph like this talking about the electromagnetic spectrum. If you end up taking physics, so electricity travels in waves. The electromagnetic spectrum, again, energy travels in waves. You also have like businesses. So, like any kind of seasonal business, might go up during Christmas, down during the summer, up during Christmas, down during the summer. So we need functions that kind of represent that cyclic cycle. So that's what we're going to use trig functions for. But we do need to know a little bit of vocabulary. So here we go. So it says periodic functions are functions that repeat exactly in regular intervals called cycles. So that's called cycles. Trigonometric functions are periodic. So here's the things where you need to really pay attention to. Period. Period is the length of a cycle. Periods can start at any point on the graph. So a period would be, if we start here, a full period would go to here. So notice how it goes up, it goes back down, and then it ends at the same height, if you will, or the same y as how it started. So the period can start and stop as long as it stops at the same place that it starts. So for example, if we start at the top of a hill, we can go down and then back up. So then here would be another period. That would be the same length no matter where you start it from. Okay, so this horizontal length would all be the same. So we can write, this would be an example of a period. So then we've got this other thing called amplitude. So amplitude is defined half the distance between the minimum and the maximum values. Basically, if we start here, how far up and then how far down do we go? That's our amplitude. So if we're looking at our graph, we have our amplitude. We're going to try to spell it right as well. So period and amplitude, we're going to be talking a whole lot about that. But how does a trig function correspond or turn into this wave function? Well, let's check that out. So if you're looking at the screen, there's three different things here, but we're really only focused on the circle. So if we imagine a trig function, and if we were to pick different parts of the circle as it does it, and we were to just graph those points, this is where that comes from. So as we do the trig function, as it goes around in a circle, doing all of the degrees and things like that on a coordinate plane, it creates this kind of wave pattern. And so that's where like sine and cosine, the graphs of sine and cosine come from. It's this wave cyclic pattern. So this graphic is really great for kind of visualizing how the trig function turns into a wave function and why we use it that way. So we're going to start with our sine. So the graph of our sine, it is a wave function. And as you can see, we're going to use an amplitude of 1 and a period of 2 pi. So we're in radians. It's generally best practice to graph in radians. And so the best way that I kind of graph it is if you think about sine, and you can use your calculator to verify this, or some of those triangles that we did in the first half of this chapter. But so if you find, like sine of 0. So if you do sine of 0, you're going to get 0. Okay, so then we're going to go up. And then it's best to kind of find the main features of the graph those, and then you kind of connect the dots. So our amplitude is 1, and at 2 pi, our graph is going to be up at 1. So then it's going to come back down at pi. Too far. And then at 3 pi over 2. So you can start to see this wave feature. And once you get some of those dots, then you can kind of make a nice little graph here. Whoops, see, that one went too far down. I really wanted to go down to 2, but it was at 1. So this is your parent graph of a sine wave. So we're going to do the same thing with cosine. So if we do cosine of 0, so at the origin, we're going to get 1, and then we'll end up going down, and our amplitude is still at only 1. I'm going to try really hard not to mess this up this time. Which I already did. And then, again, you can do all this stuff either with the calculator or, thinking about it if you know your trig functions. So here is our cosine, or our parent function of our cosine. So you'll notice that they should, in spite of my drawing, look very similar. So they are in fact the same wave, but the cosine is moved just a little bit. So believe it or not, you can express most cosine functions like this as a sine function. So maybe in business or science or something like that, you might not see one or the other because you can just switch between the two of them using some of the stuff we're about to learn. So now we know the beginning parts of our graph. Now we can look at, how does that stuff change? So if we are given this equation right here, so this A is going to be our amplitude. Oh no, what happened? So that A is going to be our amplitude. So we're going to say the amplitude is the absolute value of A. So let's say if you have a -3, your amplitude would be 3. It's just going to be reversed, or I guess mirrored over the x-axis. So that's why we do the absolute value there. So then the period, notice that we've got a B attached to the theta. So in the example above, that B was just 1. So our period was just 2 pi. But the period in an equation would look like 2 pi divided by the absolute value of B. So this is how you can look at an equation and pull out the amplitude and period, which will be very helpful if and when we start graphing. So we look at our two examples. It says y equals 3 times sine of 2 theta. So we can just plug and chug more or less. So our amplitude is going to be 3. That's the absolute value of 3, still 3. And then our period, according to the equation, is going to be 2 pi over b. In this case, our b is 2. So the 2's cancel out. So our period is just going to be pi. So then number 2, same thing. Our amplitude, it's a fraction, but that's okay. So it's just going to be 3 over 2 as our amplitude. And then our period, we're going to do the same thing. We are going to say 2 pi over 1/3. You all know how to do that. We're going to just flip that bottom fraction. So that's going to equal 6 pi. So our period here is going to be 6 pi. So with those two pieces of information, we can start graphing. Okay, so I'm looking at number 3. How do we graph it? Well, step 1, we know our amplitude is going to be this 4 right here. So that's how tall or how tall it is. And then our period, we're looking at, it's just 1. So 2 pi divided by 1 is still 2 pi. So the way I graph it, so number 1, I find some reference points. So what does sine do at x equals 0? That's an easy one that most people can either remember or just use your calculator, that's fine. So in this case, when theta equals 0, sine is going to be 0, so I've got a dot right there. So then my period is 2 pi, so that means I know that I'm going to have another dot right there, and I can go this way. And I know that I have to go up and I have to go down in between there. So that means that we're going to have a peak right here and a peak, or another peak right there, and we're going to cross directly in the middle. So that's where we'll make our blue. So our blue marks is where our amplitude is going to come into play. So then it is going up. That's how sine works. And let's see here. Our amplitude is 4. So we're going to have a dot up here. It's going to go down, and then a dot down here, and it's going to come back up. So our graph is going to look like that. And then we can do the same thing over here. This one's going down to -4, up to +4, and we can then finish it out. So knowing how this stuff works is going to be very helpful when we start messing with all the different graphs. Okay, let's do a cosine. So here we've got number 5, 1/2 times cosine 3 theta. So our amplitude is going to be 1/2. And then in this case, our period, which is 2 pi over, our period is just going to be 2 pi over 3. And so then from there, we can jump in on this. So again, I always like start at 0. So if I plug 0 into here, right this, so theta equals 0, 0 times 3 is still 0. So cosine of 0 is going to be 1. So at that point, we're going to be going to whatever our amplitude is. So in this case, it'd be 1 times 1/2. Ooh, it's going to be a very tiny graph. So we're starting at the top. And then our period is 2 pi over 3. So that means we go to 2 pi over 3-ish. So our period is 2 pi over 3. So that's a little bit lower than pi over 4. So I'm sorry, 3 pi over 4. So this number is 3 pi over 4. So we're just going to go a little bit before then and put a dot right there. So then halfway in between that, we're getting a little off of the lines, but that's okay. So our period has to, so we come up, then we have to go down and then come back up by the time we get there. So here's our halfway point, and then halfway in between there and there, we're going to go down and then up, and then we'll just keep it going. Obviously, my graph is not to scale. It's not the best because this should have only gone down to 1/2, but that's okay. So as long as your graph is close and you have your amplitude and period identified, you should be okay. So looking at number 7, our amplitude is 1 because there is no number there. So it's an implied 1. And then our period is going to be 2 pi over 3/4. We're going to multiply by the reciprocal. So that's going to be 8 pi over 3. Another 3. These 3s are kind of hard. But that's okay. So cosine at 0, our amplitude is going to be 1. So we're going to be up here. So 8 pi over 3. That's actually going to be even further back this way. So then let's see here. Pi over, so our halfway in between 8 pi over 3 is going to be 4 pi over 3. So that's something we can find. That's a little bit before here. So we're going to call that our halfway point. So this is where it's going to go down on the amplitude. So then we can kind of connect these dots, and it's going to go way out there. And then let's see here, another one right before. So there you go. All right, looking at number 9, this one's not going to be as bad. We're avoiding those 3 fractions. But anyway, our amplitude is going to be this number right here. So that's going to be 3. Our period is going to be 2 pi over 2, which equals pi. And so that means we've got sine of 0. So at sine of 0, our graph is at 0. Okay. So then our period is pi. So that means that we need to be back to our original starting point there. Halfway is right here. That means that's where we're going to cross the x-axis again. And our amplitude is at 3, so that's right there and right there. So our amplitude is going to be up here. We got a dot here, and then all the way down here. And now we can make a halfway decent graph. We'll add some more points so that I can get a little bit closer. And this is how you graph sine and cosine. I'm just going to make the rest of this up. So there you go. Let's try some tangents. So tangents get to be a little weird because they're the only ones with asymptotes. So they're going to have, and you can check this on the calculator if you've ever gotten a tangent of something and it's undefined or error or whatever. So that's because you found an asymptote. So our parent function has an asymptote at pi over 2, and then has another one at negative pi over 2. And then the right side goes up, and the left side goes down. And then that just periodically repeats. So let's see, 1, 2, 3, 4, 1, 2, 3, 4. Got another asymptote here, and then this one goes down, that one goes up, this one goes off the screen, that one goes down, and then so on and so forth. So the amplitude here is undefined. So there is no undefined minimum or maximum because it's going on forever in both the up and down directions. The period is defined, and it's going to start off as just pi. So just like the sine and cosine, we have some algebraic terms that we can figure out. So here we go. We've got a times tangent of b theta, where theta is in radians. So the period for tangent is going to be pi over the absolute value of b. So that's a little bit different for sine and cosine. So make sure you're aware of that. And the asymptotes are odd multiples of pi over 2 times b. So this seems like something that would be really helpful to go on a note card. Hint, hint. All right, let's try some examples. So looking at number 1, we've got this 2 in front. Now remember, that's not the amplitude, but if you imagine that it's like stretching a little bit, so our normal tangent function kind of looks like this. So this one is just going to look like this a little bit more. Because like I said, it's kind of stretching a little bit. It's kind of a way to imagine it. But we do have a definition for the period. So the period is going to be pi over b. In this case, our b is just 1. So our period is going to be at 5. And remember, the asymptotes are odd multiples of pi over 2b. B is currently 1. So it's going to be odd multiples of that. So that means that, so we're going to have an asymptote at pi over 2. So I'm going to draw a dotted line there. And then negative pi over 2. And then from there, it just repeats periodically. So like there's 1, 2, 3, 4. So 1, 2, 3, 4. put another asymptote. 1, 2, 3, 4. 1, 2, 3, 4. So then, again, like I said, we're going to stretch the graph just a little bit. So it's going to kind of look like this. And then this is our tangent graphs. But not least, so we've got this one right here. Again, our amplitude gets smaller. It's not a real amplitude. It's not real, but kind of helps us draw a little bit better. Our period is going to be pi over 2. So we've got this 2 right here. And remember, it's the formula is pi over b for the period. And then our asymptotes is odd multiples of pi over 2b. So that's going to be pi over 2b. In this case, b is 2. So we're going to have pi over 4. So let's see here. This is pi over 2. We divide that in half. Pi over 4 will be 1 right here. And then 1 right here. So this graph is just going to be our tangent graph, but it's going to be like super squished. So we'll make another one over here. And I'm not going to do all of this. You guys don't have to watch me graph a whole bunch. So this is what tangent graphs look like. Now, admittedly, sine and cosine graphs are more useful in the realm of like science, finance, all that good stuff that I talked about. Tangent is a little less so, but it's still really good to know, and it's a thing that you will need to know as well. So let's try some out. I will see you in class.